Okay, so let's do some review. Yesterday was a pretty easy day, right? Yes, Mrs. Mahler. Matrices are used to what? Organize. Fantastic. Dimensions of a matrix are read by row by column. That pretty much sums up yesterday, right? All right, I'll be able to perform operations using matrices. I'll be able to explain when a matrix does not exist and why. Okay, so yesterday we had something like this. Remember that? That was the very beginning exercise that we did. Just out of curiosity, what is the dimensions of this matrix? Not a 2 by 2.
1 by 3.
It's a 2 by 1. Because look, this is one piece of information that matches up with this piece of information. Correct? Yes. It says this is equal to this. And this is equal to this. Is that easier to see now that it's a 2 by 1? It is a 2 by 1. The only time something is, see how there's space in between there? That makes two different pieces of information. That's one piece of information. Evan, does that make sense?
No.
Okay. I'm gonna lose you for a second, and then I'm gonna bring you back. Okay? Hopefully it'll make sense in just a second. All right. So if the above matrices can be expressed as 7H plus 15S equals 330, and 8H plus 16S equals 360, then what would you expect for the following? Then how would you expect the following be performed? Evan? Good. You see how one thing has to match up with another thing? Is there two things to match up over here? There is? If this was a 2 by 2, this would have to be a 2 by 2. Make sense? Okay. All right. So we're adding matrices. Find A plus B. Yes, you have to do all of the work to get credit. These are not hard things. The reason I want you to write it out is because matrices later gets a little hairy. So you got to practice with the easy stuff to keep it organized. Okay? And you're going to think it's way too much work right now. It's really not that much. Okay. So find A plus B. This is how you would do this. A plus B equals 6, 4, negative 1, 0, plus negative 3, 1, 0, 3 equals 6 plus negative 3, negative 1 plus 0, 4 plus 1, and 0 plus 3. This is 2 square matrices. 2 by 2. 6 plus negative 3 is 3, 5, negative 1, 3. A 2 by 2 plus a 2 by 2 will always be a 2 by 2. Question? See why I didn't think you had to write it? Find A plus C if A equals 4, 1, negative 2, 5, 0, negative 1, and B equals negative 6, 7, negative 9, and 3. What do you think? How do you do that one?
We just put it go after how they were.
No. No.
Does not. Oh.
A plus B does not exist because A is a 2 by 3, right? And B is a 2 by 2. You can't add a 2 by 3 with a 2 by 2. It doesn't work. Yeah. Then you could add it, yeah. Okay. All right, moving on. Subtracting matrices. find A minus B if A equals this and B equals this. A minus B equals 3, 2, negative 1, 0, minus negative 2, 1, 0, negative 1, equals 3 minus negative 2, negative 1 minus 0, 2 minus 1, and what's my last one? 0 minus negative 1. You don't have to do the negative negative. I don't really care about that, but you do need to write these out. So for this problem, I should see 1, 2, 3 sets of matrices. So what's my final answer? 5, 1, negative 1, 1. Questions? All right, school athletes. So the table below shows the total number of student athletes and the number of female athletes in 3 high schools. Use matrices to find the number of male athletes in each school. So how would I find the number of male if I have the total and the female? Subtract. 863, 472, 1023, minus, Evan, get out your calculator. $863 minus 281, 472 minus 186, 1023 minus 346. Do we have answers? $582, 286, that doesn't make any sense, right?
This is why we don't use calculators.
Exactly. $677.
Now I have to question every answer he gave me.
Let's check. 3 minus 1 is 2. 2 minus 6 is 6. 3 minus 6. I think he's in the right area now. Okay? Okay. Questions on this? Okay. Multiplying by a scalar. So this says if A equals this, find 2A's. So 2 is a scalar. So 2 times 2, negative 1, 0, 1, 3, 5, equals. No. It can't be this easy. You can't have your pie and eat it too, right? Okay. 2 times 2 is 4, because I said so. 2 times negative 1 is negative 2. 2 times 0 is 0. I told you, Evan, why you have to organize it with the easy stuff, right? So that you're used to it. Then when the hard stuff comes, it won't be so difficult. 2 times 1 is 2. 2 times 3 is 6. 2 times 5 is 10. Okay? These first few chapters, these first few sections of this chapter are just kind of introducing you to something you've never seen before. Okay, so concept summary, properties of matrix operations. Basically, this thing says that matrices are commutative, associative, and distributive. Got it? Okay. Combination of operations. So if A equals this and B equals this, find 4A minus 3B. So 4A's would be 4, 2, negative 1, 3, 0, minus 3B's, equals, I would do this one in steps. 8, negative 4, 12, 0, minus negative 6, 0, 3, negative 3. No. I'm multiplying by a scalar and then I'm subtracting. So now I'll do 8 minus the opposite of negative 6 is positive 6, negative 4 minus 0, 12 minus 3, and 0 opposite of negative 3 is positive 3. Negative, negative. So 14, negative 4, nine, and 3. Questions? No? That's as hard as it gets today. All right, what did you learn today? Operations of matrices. Hold on. Nope, nope, nope. Everybody freeze. What is a scalar and why is it called that? It's whatever you're multiplying a matrix by. Why would they call it a scalar? Because what? You're scaling it. Right? You're scaling it either up or down. If I'm scaling up, I'm using multiplication. If I'm scaling down, what am I doing? Or multiplying by a fraction, right? Same thing, right? Cutting it into pieces. Okay. I know a matrix is impossible when what? When the rows and columns don't match or the dimensions are different. Okay. That's it, guys.